Okay, everybody, going to work on these questions here for preparation for the quiz. Excuse me, this is not a quiz review. These are just some questions that will help you to understand the concepts better. I'm going to try to keep this fairly quick, so I'm going to move along kind of rapidly. If you need to pause the video to think about things, go ahead and do that. All right, first question is simply giving you f of x equals 2x squared plus x minus 15, and they're asking you to evaluate this at negative 1/2. So this means that negative 1/2 will go in for x. That's going to be 2 times negative 1/2 x squared rather, plus negative 1/2 minus 15. Let me fix this here, this pen, make it skinnier. That's going to be 2 times 1/4 minus 1/2 minus 15. These actually cancel out. That's 1/2 minus 1/2. And you get negative 15 as your answer. So that's part A. X-intercepts and y-intercepts. I'll do the y-intercept first. It's easier. We're going to let x equal 0. So basically, what is f of 0? And that is 2 times 0 squared plus 0 minus 15. That's negative 15. So when x is 0, y is negative 15. X-intercept, we're going to let y equal 0. So that's f of x equals 0. 2x squared plus x minus 15. Here's a quadratic. We've done plenty of these earlier in the year. This can be factored and solved. So I'm going to say 2x and x and probably 3 and 5. I think it's going to be plus 3 here, minus 5 here. And I set each individual factor to 0. So for this factor, I get x equals 5/2. And for the other factor, right here, I get x equals negative 3. And we're good to go. And then find where f of x equals 21. That means find the value of x that makes the function equal to 21. So let's do 21 equals 2x squared plus x minus 15. It's a quadratic. It needs to be equal to 0, most likely, before we can solve it. So I subtract 21 from both sides. And let's factor this. I'm going to continue it right here. 0 equals, let me see here. Let me move some stuff first out of the way. 0 equals, what is that going to be? 2x and x again? Let's see. How about 2x plus 9, x minus 4? So x can be negative 9 over 2 or 4. And that's the values of x where the function is 21. All right, number 2, we have a linear function, g of x, and they're giving us 2 points on the curve. Not on the curve, on the function. First point they're giving us is 2, 5, and also negative 1, negative 3. It's a linear function. That means we can find the slope. So that's going to be 5 minus negative 3 over 2 minus negative 1. That's 8/3. And the point on the line is 2, 5. So let's say we have y minus 5 equals 8/3, x minus 2. Let's solve this for y. Y equals 8/3 x minus 16/3. Distributing the 8/3 plus 5. What is that? Plus 1/3 minus 1/3. And because it's in function notation, let's take away the y and let's just call it f of x or g of x. There's our first function right there. Now they also give us a function h of x, and they give us a point on here. H of x only has 1 point, but we do know that it's perpendicular to the beginning line. So if the slope of the first line is 8/3, then the perpendicular slope for h must be negative 3 over 8. Now, if that point over here, h of 0 equals 3, if that's 0, 3, Isn't that the y-intercept? So isn't the equation of this line, h of, oops, hang on. Isn't the equation of that line, h of x equals negative 3/8 x plus 3? Yes, it is. So there you go. And that's my h of x function. All right. Excuse me. Part B, I did this one earlier in class. It is kind of a pain in terms of the numbers. I don't think I'll ask you to do a crazy one like this on the quiz. However, the quiz is only 6 questions, so it's not really that crazy to ask you to do. We're going to do it. So here we go. I'm going to be going side to side here because there's not a lot of room on the paper here to work. So we're going to have, where do G and H intersect? So I'm going to say 8/3 x minus 1/3 equals negative 3/8 x plus 3. I don't want to do fraction math. I'm going to multiply by 24. And that's going to give us 24 over 3 is 8. 64x minus 8 equals negative 9x plus 72. And if I bring the x's to the left, I get 73x. I bring the numbers to the right, I get, did I get 80 today? I don't think I got 80. Let me double check this. (24 over 3 is 8, 64. (24 times 1/3 is 8. 3/8, negative 3/8 x plus 3. Multiplied by 8. Multiplied by 24. No, I think that's right. Okay, so x is, if you see an error in my math, maybe put it in the comments or let me know, and I will, or let anyone else know who's watching this video. We got the x value. When you want to know where lines intersect, we need an x and a y. So I can plug this x value into either function. I'm going to pick h of x because it just looks a little more manageable to me. It's fewer fractions. So I'm going to say y equals negative 3/8 times x plus 3. Well, 80 over 8 is 10. So what's that? Negative 30 over 73 plus 3. 73 times 3 is 219 minus 30, 189. 189 over 73. So that's my intersection point. 80 over 73 and 189 over 73 is my final answer. That does not, oh, you know what? I think that is right. I did this in class today, and I think that's right. Okay, number 3. In each pair of relations is A or B, or both or neither are they functions? Well, number 1, I'm going to highlight the ones that are. I'm going to use a pen for now. This equation here is just a line in standard form. It's a slanted line. So it's a function. It passes the vertical line test. Letter B is a horizontal line, which also passes the vertical line test. For part A, I meant to say vertical line test. I'm not sure what I said. So they both pass the vertical line test, therefore they're both functions. In the second example, we have repeated values of x that pair up with different values of y. That is not permitted if it's going to be a function. However, for function B, we have all different x's pairing with the same y. That is permitted. So in example 2, B is a function, not A. In the third example, you may not know what these graphs look like. Let's start with B. Y equals the absolute value of x. That is simply a graph that looks like a V, and we'll be studying this more soon. Anyway, that passes the vertical line test, so that is a function. If you're doing this at home, you can always put them in Desmos and see if it's a function or not. I'm not going to quiz you on things that we've done very limited work with, so don't expect to see me asking you a question exactly like that. Part A of this one, you probably don't know what it looks like. It's an absolute value graph, but it's flipped on its side. This does not pass the vertical line test, so it is not a function. So for number 3, we have both. and then b is a function, and then b is a function again. All right, number 4. Using these function rules, f of x is negative 2x minus 3, g of x is x squared minus 1. Let's find all this stuff. We're just plugging in values and seeing what we get. Letter A, f of 3, negative 2 times 3 minus 3. My math says that's negative 9. Letter B, g of negative 3. We're going to square the negative 3 and then subtract 1. You all know when you square a negative, you get a positive. 9 minus 1 is 8. Number C, letter C, f of negative 3. That's negative 2 times negative 3 plus 3. I think that's 9. Nope, sorry, it's minus 3. Let's go backwards here. Minus 3. That's 3. Plus g of 3. I'm going to do this mentally. 3 squared minus 1 is 8. 3 plus 8 is 11. And finally, negative 2 times f of 3. Well, we just did f of negative 3. It's right here. That is 3, right? So I have negative 2 times 3. And then 5 times g of negative 3, which I did in part B. That value is 8. Let's simplify that. Negative 6 over 40, which reduces to negative 3 over 20. There you go. Number 5, write a function rule for the following scenarios. I wonder if this is linear or not. I'm not going to assume that it is, and you really can't tell by looking at it. The points aren't in order. Let's take the slope between these 2 points and these 2 points, and then if they're the same, then we'll know it's linear. So from point 1 to point 2, my slope is 1 minus negative 1 over 7 minus 3. That's a half. And in the second pair of points, negative 5 take away 1 is negative 6. Negative 5 take away 7 is negative 12. That's a half. Yes, this is linear, where the slope is a half. So can't we just say point slope form? I'm going to pick at this point. Y minus 1 equals 1/2 x minus 7. Now they do want it in function notation, right? The function rule. So I'm going to solve for y, but I'm going to call it f of x equals 1/2 x minus 7/2 plus 1. That's minus 5/2. I'm going to rewrite that a little neater. 1/2 x minus 5/2. All right, letter B. The score you get on a test if you lose 7 points for every wrong answer. So if x is the number of, I can write. If x is the number of wrong answers, then your score, let's call it S of x, is 100 minus 7 for every question you get wrong. So that's the score function depending on x, where x is the number of wrong answers. Number 6 is a review. We're going to skip it. It's not on the quiz. Number 7, the function g of x is created by a set of transformations, blah, 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 blah. What I don't like about this question is that this one has 2 transformations to x, which we did not discuss in class. It's a little more complicated. For the purpose of this video, I'm not going to cover it. We can, let's see real quick here. Let's just, for right now, let's pretend that it's just x minus 2. Let's take this out, and I can do this actually pretty cleverly. Let's just do this. There we go. All right, so now, let's pretend it looks like that. So now we can answer the question. For our class, we only did one change corresponding to x. So write out the set of directions you would give someone if they were trying to take the graph of f of x and create g of x based on it. Well, remember we start inside. Okay, so what does that tell us to do? Number 1, we have to move the graph to the right by 2. Then we work outside of the function but stay attached to the function by multiplication. And when we multiply a function by a number greater than 1, it's going to be a vertical stretch by a factor of 3. And finally, when we add a number to the end, right here, that means we're going to go up. We're going to transform the function by going up 1. And that's it. Let me read those directions again. Write out the set of directions. Move it to the right 2. Yeah, that's it. And then that's the order you should do them in. Start inside and work your way out. Follow order of operations. Okay, number 8, given the graph of y equals f of x on the same pair of axes, graph the following. All right, so here we're going to go right 3, number 2, reflect over the x-axis, and number 3, go up 1. I'll do this in black because we're going to fit 2 on the same graph here. Okay, so I'll take each point, go to the right 3. So it's going to move me. It's going to move me here. I'm going to delete these every time, so we're there. Then we're going to reflect it over the x-axis, so that's going to be up here, and then up 1, which puts me there. Let me erase the other points. Okay. The second point, which is here, I'm going to go right 2. Oh, darn it. I have to start that over. I don't think I did that right. I did read my own directions. It was covered up. Okay. To the right 2. Vertical stretch by a factor of 3. No. Oh, I'm reading the wrong. Oh my God. I'm reading above. It's right here. Okay. To the right 3 puts me here. I did it right the first time. Vertical, reflect over the x-axis, and then up 1 puts me here. If I had time to edit this, I would edit out the last minute. I don't have that kind of time. Second point, which is up here, we're going to go right 3, which puts me here. Reflect over the x-axis puts me here, and then up 1 puts me there. All right, so we have that. The third point is like the end of that. Actually, I'm going to do this point here. Go right 3, reflect over the x-axis, keeps it there, and then up 1 puts me here. All right, so we're going to get rid of those points. Next point is at the top of the straight line right here. Right 3 puts me here, reflect over the x-axis puts me here, up 1 puts me there. And the last point, which is down here. Right 3 puts me here, reflect over the x-axis puts me there, up 1 puts me there. And then just like when you were a kid, connect the dots. So we have, let's see, I think I missed a point. I missed this point. I missed that point. Right 3 puts me here, reflect here, and end up there. Now I'm ready. Okay, so now we have a straight line, a curved shape, a kind of flattish line right there, and a straight line to end it, like so. All right, and then there is, I'm actually going to erase that, but if you want to pause or take a screenshot of this, that's going to go away. Okay, so we're done with that. Okay, and then second graph I'll do in red. All right, we'll go red here. All right, now we're going to go reflect over the y-axis. Number 2, vertical shrink because it's a fraction less than 1 by a factor of 1/2, and then up 3. And I've got 1, 2, 3, 4. I think it's 1, 2, 3, 4, 6 points to do this to. So here we go. Starting with this point here, reflected over the y-axis. So it's going to be 7 in this direction. So 7 and 7 puts me here. Vertical shrink by 1/2 puts me here. And up 3 puts me there. This one's going to be a little harder. This point here, reflect over the x-axis. So it's 1, 2, 3, it's 5. 5, reflect puts me here. Vertical shrink puts me at 1.5. Up 3 puts me at 4.5. Okay. The bottom of the bump here, reflect over the y-axis, puts me here. Vertical shrink times 1/2 keeps me there. Up 3 puts me here. This point here, reflect over the y-axis puts me here. Vertical shrink puts me there. Up 3 puts me here. Kind of makes sense that it's in line with that other point. Yeah, this one here, right? And can you tell, like, this little bump here kind of got flattened out? It's a vertical shrink of 1/2. So everything is compressed by a factor of 1/2. What haven't I done? 2 more points. This point here, let's do that. Reflect over the y-axis puts me here. Vertical shrink by 1/2 puts me there. Up 3 puts me there. All right. Last point. This one, reflect over the x-axis puts me here. Vertical shrink by 1/2 puts me there. Up 3 puts me at 1.5 right there. Now let's see what we have. We have the flat, whoops, darn it. We have the flat line, the kind of curve, this flatness here, and this flatness there, that line. And there you go. You can kind of tell it's been flipped over the y-axis. It's been compressed. And you can definitely tell it's been moved up, I think. Okay. Number 9. Here's the original graph. It's a absolute value function. Right? So this one, really what I want you to be able to tell, it's been flipped. It's been reflected over the x-axis. Can you tell it's been like stretched out compared to the original function? This one's kind of wide, and this other one is much skinnier. So we're going to think about this on a vertical basis. I'm not going to give you a stretch like this or ask you to identify the stretch from a graph. I'm just going to tell you that this slope looks like it's up 1 big box and over 1 big box, so the slope is 1. The slope here looks like it's kind of down 3 big boxes and over 1 box. So I'm inclined to think that the slope is 3 times as steep. So it's been stretched vertically by a factor of 3. Now, again, I'm not going to make you recognize that on the quiz, but I'm just pointing it out here because it's on the quiz. And this vertex, once I flipped it over and once I stretched it out, that vertex has moved to kind of like right and up. That one I think is easier to tell because it's been moved right 1 and up 2. All of this so you can actually identify what the transformed function is. So my original is f of x equals absolute value of x. And let's apply these changes in order. Well, certainly right 1 would give me x minus 1 inside there. I've done that. Up 2 would be a plus 2 on the outside. And then the vertical stretch times 3 and the reflection over the x-axis puts us there. That is the transformed function right there. Okay, there's 2 more to go. Given the domain of a function is listed as follows. Remember that, and the range is as follows. What would the domain and range of g of x be if this is the g of x transformed function? So if you remember in class, we talked about that this horizontal transformation should be accounted for. And we're going to replace the x in the original domain with the argument in the new function and solve for x. For us, it's as simple as just subtracting 3 from both sides, and this is our new domain of g of x. For the range, you're going to take those original y values of the range, and you're just going to apply the actual changes to the function, which is that y got multiplied by -1/2 and then added 7/2 to it. So let's multiply by negative 1/2. That's going to make the signs flip. We're multiplying by a negative. So that's going to be a 1 and a 19/2, but negative. And if we add, no, yes, yes. Then if we add 7/2, there we go, plus 7/2. 1 plus 7/2 is 9/2. And negative 19/2 plus 7/2 is negative 6. So the range has to be between negative 6 and 9/2. That is my range. Okay, the last one, by the way, 12 is a review problem. It's not on the quiz. For number 12, the domain for a rational function, a fractional function, you're going to set the denominator equal to 0. So 2x squared minus x minus 10 equals 0. This looks like it can be factored. 2x and x, 2 and 5, minus plus. So the thing that makes either of these factors equal 0 would be 5 over 2 or negative 2. And for that reason, we exclude them from our domain. We don't want the denominator to equal 0 because that means we're dividing by 0. That can't be done. Okay, so my domain is there. I'm not going to ask you a range just yet. We don't know enough about these to determine the range from just an equation. So we're going to leave that. The x-intercept, remember, let y equal 0. Super easy, right? Let y equal 0. So I have 0 equals x minus 1 over 2x squared minus x minus 10. Well, wait a second. That's not easy. That's a weird looking thing equal to 0. Well, actually, it's just a fraction. So when does a fraction equal 0? Well, a fraction equals 0 whenever its numerator equals 0. So all I have to do is set x minus 1 equal to 0. And when x equals 1, or rather, shall I say 1 comma 0, then when x is 1, then the function equals 0. That's my x-intercept. My y-intercept is even easier because all I have to do is let x equal 0. Let me go back and check that function. I'm really just finding f of 0. So f of 0 is 0 minus 1. I don't even need to write this out. You can do this mentally. 2 times 0 minus 0 minus 10. That's 1/10. Check it for yourself. So you get 0 comma 1/10 is my y-intercept. Now that I've done all these, that's a pretty fair assessment of what the quiz will be like. Similar in length, 2 sides of a page, between 6 and 8 questions, 36, 40 points, something like that. All right, so period 8 has it Friday, period 7 has it Monday. We're going to wrap this video up.